All right, welcome. Today, we're going to dive into something pretty amazing, computer vision. This is the tech that's literally teaching machines how to see and make sense of the world, kind of like we do.
So, that brings us to the big question, right? Can a machine really see? It sounds simple, but it's a huge deal. And that question is really at the heart of what we're going to unpack today. Okay, so to get to an answer, we first have to figure out the how. How does a machine actually look at the world and process what it's seeing? It's not exactly like our eyes and brain, but you might be surprised by the parallels.
A good way to think about it is to compare it to our own vision. A camera, well, that's like the machine's retina. It just captures the light. But the real magic, that happens in the algorithms. They act like our brain's visual cortex, taking all that raw data and trying to find meaning in it.
See, to a computer, this picture of a fish isn't a fish, not at all. It's just a grid made up of thousands, maybe even millions of tiny little dots we call pixels. Every single pixel is one point of color, and when you put them all together, you get the image we recognize. The more pixels, the more detail the machine has to play with.
So how does a computer actually read these pixels? Well, each one gets a number. For a really simple black and white image, it could just be a 1 for black and a 0 for white. This whole process is called digitization, and it's how we translate the visual world into a big grid of numbers, a language the computer can finally understand and analyze.
Okay, so the machine has the image as a giant spreadsheet of numbers. Now what? How does it go from that to actually understanding anything? Well, it follows a very structured 5-stage process. It's like a pipeline that turns raw data into something useful.
Think of this whole thing like a digital assembly line. It starts with acquisition, just getting the picture. Then it moves to pre-processing, which is all about cleaning it up. After that, extraction and detection find the important stuff, and it all leads to the final stage, high-level processing, where the machine figures out what it all means. Let's walk through each one.
First up, image acquisition. This one's pretty straightforward. It's exactly what it sounds like. You're just capturing the visual data, whether that's with a camera, a scanner, whatever. This is ground zero.
Next comes a step that is absolutely crucial, pre-processing. You could almost call this the unsung hero of computer vision. The whole point here is to clean up the image, because the better the quality at this stage, the more accurate everything else is going to be down the line.
Here's a perfect example. Look at the image on the left. It's grainy, it's noisy. Then look at the right, after noise reduction. So much crisper and clearer, right? Getting rid of all that blur and those random spots makes it way easier for an algorithm to pick out what matters, like the flamingo and the mountains in the background. Another key task in pre-processing is just simple resizing. Machine learning models, they like consistency. They often need every single image to be the exact same size. So all the images get resized to the same dimensions to make sure the model can process them without any hiccups.
Okay, now we get to the really clever stuff. In stage 3, feature extraction, the machine starts looking for basic patterns, things like edges, corners, and different textures. Then, in stage 4, detection, it uses those patterns to actually find and separate out whole objects in the image. And here you can see two of the most important tasks in action. The first one is classification. That's just identifying what's in the image. It says, hey, that's a dog. The second one, localization, takes it a step further. It draws a box around the dog and tells us where it is. That simple addition of where was a total game changer, and it's what makes things like self-driving cars even possible.
And that brings us to the final stage, high-level processing. This is where everything we've done so far comes together. The system takes the objects it found and identified, and it tries to understand the whole scene. From there, it can finally make a decision, or a recommendation, or just take an action. This is basically the brain of the operation.
So that's the 5-step process. But where does this technology actually pop up in our day-to-day lives? Well, the answer is pretty much everywhere. Let's look at some real-world examples you probably use all the time without even thinking about it.
I mean, just look at this list. The range is incredible. You've got facial recognition for unlocking your phone or tagging friends in photos. It's revolutionizing healthcare by helping doctors analyze medical scans. And of course, it's the absolute core of self-driving vehicles, just to name a few.
One of the most common places you'll see it, it's right there in your pocket. The way your phone just unlocks when it sees your face, that's a super sophisticated computer vision system doing its thing, identifying your unique facial features in a split second.
And then you have the really futuristic stuff. Self-driving cars depend on a constant stream of visual info.
They're using computer vision every single second to spot other cars, read traffic lights, and most importantly, detect pedestrians to keep everybody safe.
But, as powerful as this all is, it's not perfect. There are some major challenges and some pretty serious ethical questions to deal with. Giving machines the power of sight, well, that comes with a lot of responsibility and some really tough problems we need to solve.
We're facing some big hurdles. For starters, machines still aren't great at reasoning. They can tell you there's a car in the picture, but they often miss the bigger context of the scene. Simple things like bad lighting or a weird camera angle can still completely throw them off. And then you get into the huge issues around privacy with things like facial recognition. And of course, the fact that this same tech can be used to create convincing fake content, like deepfakes.
And that last point is a huge risk. As our source material puts it, computer vision introduces challenges related to the proliferation of duplicate and false content. The ability to create fake images and videos that look real, well, that has the potential to spread a ton of misinformation and cause some serious damage. And that leaves us with this final, really important thought. We've seen how machines are learning to see, the amazing things they can do with that ability, and the serious challenges that come along with it. As this technology just keeps getting better and better, the real question for all of us is the one on your screen. What should we be looking out for?